Welcome and thank you for joining us today. We're so happy to have you join us. If you don't know CED Greentech yet, I invite you to talk to us after the webinar, and how we can support you on your needs, your Panasonic solar and storage needs, through our 58 locations nationally. During this difficult time, we're especially honored to have over 600 folks register for this webinar, which is an amazing number. To hear Dan Glaser, who's parenthetically has worked at CED Greentech, and he's been in the industry for over 15 years, and now he is the lead sales engineer at Panasonic. Without further ado, I'd like to welcome you, Dan.
Thank you very much, and thank you, CED, for hosting us. This is our honor to join and present to your team, the installers, and present some, I think, much needed information into the industry. So very happy to be here.
We're happy to have you.
So we can go ahead and just a few housekeeping rules. We're going to go ahead and present the slide deck first, and then we're going to wrap up at the end with questions. So we will be sending out the slide deck afterwards, and we will try to address all of the questions that we can within the time that we have. But I know there's a lot of great information here, so we will get to what we can. And then this is available for NABCEP credits as well, and we will have this recorded. So in case you guys have to jump off, or if any of your teammates are missing it. So my name is Dan Glaser. Hopefully I know many of you out there in the internet land here, but I've been in the industry for quite some time through various module manufacturers, distributors, and even a racking company out there. So hopefully all the friends and family out there with familiar faces. And again, thank you very much, CED Greentech, for hosting us and joining us with this webinar today. I think hopefully you guys get a lot of benefit out of it. You get to understand not only the Panasonic EverVolt product and energy storage and how to simplify your sales in your business, but also just kind of the story behind Panasonic and how that can also differentiate you guys out in the field. So the agenda today, we are going to start with kind of the story, the background. This really is one of the key differentiators that we have in the industry. We're very fortunate to have a rich history, and particularly with battery technology. And then we're going to jump into energy storage and how does it work. Kind of dive into some of the quality aspects that really there's not a whole lot of great information out there these days, especially in the residential land. And then we'll talk briefly about Panasonic's new entry into the energy storage space with EverVolt. So just a story behind the company. So many of you may not know, but we're over 100 years old. This is our founder, Konosuke Matsushita, and this is kind of a unique, he was a visionary ahead of his time for sure. You can see here, his main mission was to create material abundance by providing goods as plentiful and inexpensive as tap water. We revolve around 25-year business plans. So kind of, for some people, that's an entire career time span. So we don't think in very short terms, but the long term. Batteries, many of you might know from the EV industry, and perhaps you remember some of the battery technology that was around in the 90s and 2000s with our lithium batteries, the rechargeable ones. But batteries, we actually have been doing them all the way since 1923. Our founder saw a need in a bicycle battery-powered bicycle lamp. And so it goes back a very, very long ways. And this is really important and differentiated, especially in today's world where plants are popping up all over the place with different manufacturing, different technologies. We really rely on our history, our knowledge, what has worked in the past, and the design and the engineering that our team has learned over the last almost 100 years of battery technology. So this is just a timeline. I'm sure that you guys can't really read it, but just kind of the main Takeaway again is dating all the way back to 1923, you see here. And then 1931 was a pretty pivotal moment where we started in-house production of dry batteries. And then this translates all the way through the last century, where we have our rechargeable batteries and then the batteries that we have inside of electric vehicles. So batteries, again, they've been around in our blood and our DNA for a long time. As many of you are familiar with, we are one of the largest battery manufacturers globally. We have the partnership with the Gigafactory in Nevada, where we have our battery production, along with other global locations as well. The main point of this slide is just to kind of show, there's a lot of production out there, especially as the EV market grows, the energy storage market grows. It's really kind of centered around just a few kind of larger manufacturing players in the industry. And again, there's not a lot of great information or data or testing out there on the differences between, the technologies or the quality and the performance. So, relying on obviously a industry manufacturer that has been around a long time, has a successful track record, is a very important aspect when purchasing such a large or such an expensive product for the home. So why Panasonic? Again, trust. We've been in business for over 100 years. We're going to be in business clearly for much longer than that. Safety, one of the most experienced battery manufacturers in the world, putting batteries in vehicles that travel down the highway at 70+ miles per hour. You have to make sure those batteries are safe. Reliability, we've got sometimes painfully conservative approaches to design and engineering, but again, that's only going to help the homeowner, the installer, years to come. Everything is very kind of fresh and new in the residential space of energy storage. So, time will tell over the next 10+ years as far as different performance levels, different quality, different reliability factors that come into play. So how does it work? What is the right type of system to choose when going and approaching a solar customer or potential solar customer or just a homeowner that's interested in energy storage? So, I know we have a wide audience here. For those that have been doing off-grid systems in particular for the past 20, 30 years, I know there's some of you guys out there, maybe a lot. You probably know this stuff like the back of your hand, but there's a lot of people that we talk to today that interchange some of these fundamentals. So we just want to make sure we're all on the same page. So really, when you're looking at energy storage system, you have kind of two major components. You have the battery component, and then you have the inverter. Similar to solar, batteries store the power in DC. So we need the inverter to convert it to AC to use it in the home. So you have the balance between what the inverter can do, which in this example here is the faucet, and then you have your tub, which is your tank of energy, your kilowatt hours. So pairing the right size battery to the inverter in particular, and basing that off what the customer is actually going to use, is really the right way to go about designing a system. And that's really done in the commercial side of things, where a lot of expertise can be used to do that. In the residential, we try and make things simple, along with some other manufacturers that we design the complete system for you. But it's just important to know that there is a certain spigot or faucet that the energy can come in and out of. So it doesn't make sense to have too big of a tank or bathtub in this case if your inverter or your faucet is not large enough to transfer that. So there's a couple different ways to install energy storage. First of all, we'll start with the DC coupled system. And this is, it has its advantages, which we'll get into, but it's a very simple concept in where there's generally a single inverter. You have your PV array going directly into that inverter, and then you have a sub panel with your backed up loads, and these are the loads that the homeowner chooses to have during an outage. And then you have your inverter tied into your main service panel, very similar to kind of the traditional solar PV string inverter type systems. And then you have, of course, your battery cabinet. AC coupled, in this example here, you're gonna already have a PV inverter. In this case, it's a string inverter, but can just as easily be microinverters or optimizers or whatever other technology comes our way. And then that system is kind of separate from your energy storage system. So the energy storage system can interact somewhat to some degree, which we'll get in here with the PV array, but essentially they're two separate systems. This is great if somebody already has a solar system on their house and they're looking to add energy storage. It's also great if somebody is already set on using a certain type of inverter technology or has a certain preference for a different inverter technology. You can easily add this AC coupled system separately as well. So this is our energy storage product, EverVolt, but this philosophy, I would say, kind of applies to a lot of energy storage systems in the residential space out there. Is generally, the big question for homeowners is, what are you going to be able to back up with a single system? So we recommend just very basic loads, refrigerator, lights, your garage door, internet, cell phones, and of course, your coffee maker. You don't want to wake up without coffee. And so, you want to keep as little loads on the single system as possible to maximize the amount of energy that you have available, just in case, you have a longer outage, or if you're in a particular area that is prone to longer outages, you want to make sure you have enough energy storage to get you through at least the day, or at least to have your solar system fill that back up. What can you do with two EverVolt systems or two energy storage systems? You can do your basic loads, and then in general, you can also do small AC units, maybe some small well or pool pumps, electric vehicles, kind of, if you're looking at the lower charge setting, and then maybe some additional heating elements. Again, these are just very basic rules of thumb. In an ideal world, you do want to go through and really right size the system, but we know that there's a lot of time and expertise that entails with that. So we're trying to again, make the sale simple, make it palatable for the homeowner without causing too much confusion. So AC coupled. So this is again where you have a PV inverter, PV system, and then you also have an inverter with your energy storage system. So the reason it's a little bit more complicated in the design is because you need the design for the worst case. And what the worst case means is what you'll see here is that your inverter, let's just say it's the middle of summer, you've got full inverter production, your batteries are at a full state of charge, they're topped off, the homeowner is not running any essential loads, and then the grid is out. So what happens in that case is your PV array, it doesn't have anywhere for that power to go, right? So we'll simply turn it off. Now, and that's kind of the worst case you want to design for. Now, as the homeowner, turns some loads on, as that battery is starting to be consumed, maybe as the sun is going down or it's overnight, obviously then more PV power is needed. So you'll want to have your PV production up and running to recharge those batteries to power the loads in that case. But in general, you want to kind of design your PV system for the worst case scenario. So what does that mean exactly? So, again, when to choose AC coupled, if you have an existing PV system and those inverters are still under warranty. In particular, sometimes if you have an older PV system with a string inverter that is out of warranty or that is on its last legs or about to be out of warranty, maybe it just makes sense to replace that with a DC coupled system. Or similarly, if the installer or the homeowner has a preference to use AC modules or other specific inverter technology that's on the market. So again, you want to recommendation to size the system simultaneously with the energy storage system, not after the PV sale. We do see companies that they go and they install or they size the PV array, they give the homeowner a quote, and then the homeowner says, well, actually, I want energy storage added on. Can you give me a quote for that? And then it can get a little bit trickier in that sense. It can be done, but there's a little nuance to the sizing of the systems, which we'll get into when AC coupled is and you have a separate PV array. So the rule of thumb is the PV array size should not exceed the battery charge capability, right? Hopefully this makes kind of basic sense where our batteries, so for EverVolt standard, they're rated at 4.4 kilowatts of AC power. The EverVolt Plus, 5.5 kilowatts of AC. So in the very basic rule of thumb, you don't want to have more than that power available from PV, right? Otherwise, during a grid outage, that extra power is going to trip something. Now, that's the basic guideline. Now, if it's a newer inverter that you're using and it's got the UL 1741 frequency watt, volt watt certification, then it can and it is capable of responding to frequency control from EverVolt. So what this means is that your PV array can actually be a little bit larger than what the batteries can handle. And then as the PV array starts producing energy, we're in a general sense, we're basically going to shift our frequency to cause the PV inverter to shift its frequency or kind of move off of that maximum power point point on the IV curve. And that way, we're not producing as much power, the system, everything is happy, and the power has a place to go. Now there are a few additional, this is kind of, I would say, more intermediate or advanced level installer type of questions to consider during designing an AC coupled system is there a base load? So for example, if there's generally always going to be some lights on or some kind of heavier usage loads, like a refrigerator is always kicking on during the day, or a great example is a hot tub that's kicking on every hour. You can kind of plan for that and size the PV array to be able to supply that as well. You also want to consider what's the AC output of the PV array seasonally. So before you'll know that I mentioned you want to design for worst case, so that would kind of be your peak output of the annual of the year. But it makes sense in a lot of cases to look at, is this really going to be a problem? Like if there's going to be too much PV for 1 month out of the year, potentially on very bright sunny days, you can use your judgment on that design. And then again, when do outages typically occur? So if you know that your outage is typically during the summer months or the winter months or different seasons or different times of the day, you can size your PV array to handle that. And again, this is more advanced kind of sizing considerations, but the basics are above. So if you're using a newer inverter, you generally can oversize the PV array. Now, something that's fairly unique with EverVolt is we do have generator integration. So what this means is that if somebody has a concern that they need days of autonomy, or they're concerned that they're going to drain their battery bank too quickly, or they're going to need more power, and either if they already have a generator or they can buy a fairly cheap generator on top of it, the way that it works with EverVolt is two ways. One is we can integrate directly with our inverter. So that way, when the batteries reach a 10% state of charge, then we can auto start that generator and it will take over and basically power the loads until the PV or the grid comes up. PV comes on the next day or the grid comes back. The other way that we have some installers do it, which does require an external battery charger, is you can actually just use it as a simple manual start-stop. And if the batteries drain, you can actually charge the batteries directly from an external generator. So what sets EverVolt apart from the rest? Again, so we have a full solar and energy storage system from a single company over 100 years old. So trust and brand recognition. Maximum resiliency. We've got a fairly unique design in the battery, the way we stack our batteries. So our batteries are installed in parallel. So we'll get into it, but what that means is if one of those battery packs were to ever have an issue in the system, the rest of the system still operates. So it's not like your entire system goes down. You won't be hopefully getting the call on Friday evening, Christmas Eve, saying, we've got to get out here and get this system back and running. The homeowner can ideally wait a couple days. It's more of a low-level type of failure. We are available in both AC and DC coupled options. Each battery pack is only 55 pounds, so it's easy to handle, to install, to transport. And bankability, being one of the largest manufacturers, obviously we have an eye on sustainability and the way that these packs are going to be handled at the end of life. And there are some, valuable minerals and materials and great recycling capability. So having, number one, a 55-pound pack is making it easy to transport at the end of life or if it needs to be serviced. And then because of the EV industry, we've got various battery recyclers across the country that we work with to upcycle in some cases or recycle the battery. So quality, just kind of a step back and looking at basics on the chemistry here. So our EverVolt product, it uses NMC technology. Its cousin is the NCA technology for those that are familiar with EVs. The reason why this has been so popular with EVs and many energy storage systems is the energy density that it obtains. So we can get a lot of energy contained in a small footprint. That's why, in particular for our specific case, the EverVolt battery cabinet will only stick out about 10 inches from the wall. So it's a pretty slim profile, low footprint. So, what drives technology, particularly in the energy storage space? It's all about the EVs, really. That's what's driving lithium production. So generally people, will ask, what about this EV, this lithium technology or this battery technology? And kind of at least our stance on it is, well, if it's, part of the EV roadmap, very likely will come to the residential or commercial energy storage space. So I hinted on this a little bit earlier, but why Panasonic? Again, we think that choosing a reputable manufacturer is a very important part when spending thousands or tens of thousands of dollars on a solar system, but also a PV system. I mean, an energy storage system, more importantly, because it's so new. And batteries have various performance metrics that are not really published. So this is a quote from DNVGL, that independent data about performance, lifetime, and safety, it's really not out there in the residential space. So this is something that I think we're all working towards, and we're getting there. But one of the reasons you really want to fall back on the quality and the manufacturing. So this is a report done by DNVGL, a third party. It doesn't show the company names on here, but as you can see, they basically just took various batteries from the market off the shelf and put them through testing. And what they found is that not all batteries are the same or created equal. So you can see that there's clearly some leaders in there. We hope that we're one of them. I actually don't know for sure, but I thought this was a very informational slide, just to give out there. Something else we just want to kind of talk about, because we do get the question a good amount, especially in the residential space, is safety. And this is, again, straight from the DNVGL report. This is a third-party report saying that it's difficult to say that one battery chemistry is superior. They are all susceptible to fire and the emission of plastic-related pollutants. And when I talk about this, the analogy I give is kind of either your car, or maybe more prone to energy storage is like the natural gas lines in houses and things like that, where it is a very small concentrated source of fuel. So it has the potential to be a dangerous substance. You can look at the MSDS sheets of any product out there. But the real important key thing is how you design it, how the BMS works, and really managing that system is what's going to make this a safe product to be put inside of a home. Again, these are just, this is purposely blurred out here. This is proprietary information, but again, through our rich R&D and testing history, we have a lot of tests above and beyond just the requirements from UL and IEC that are out there. So battery warranty, again, the residential space is not really up to speed on this yet. There's just not a lot of information, but just some things to consider is that the better you treat a battery, the longer it's going to last. So our particular warranty, we guarantee a minimum of 60% capacity at the end of our warranty period. And that's essentially putting it in the worst of the worst conditions that you can. We are an indoor rated battery, so you do have to keep that in mind. But again, if you can keep it in a climate controlled environment, obviously keep it away from furnaces, from different big temperature swings and things like that. Maybe if you have the ability to set a lower depth of discharge and have more reserves, so you're not cycling through that, not required, but that'll get you closer. That'll just raise the performance guarantee there. You'll get 70, 80, or who knows how much higher than that, depending on how you use it over time. But minimum 60% is what we guarantee. Out there a lot, but it really, at least in our mind, it's kind of very confusing terminology. And the reason being is shown right here. So you can see that this is from an electric vehicle, actually, and you can see that various EVs, the way that you drive it, again, the climate conditions that they're in, will have different levels of capacity remaining over the various miles. So a trend line is drawn, and so that trend line is kind of what we can base an average degradation on. But as mentioned, everybody is using their system differently, or has the capability to use it differently, and everybody has different environmental conditions to deal with. So cycles are not a great way to look at things, because if somebody's using, for example, 50% battery reserve every day, where somebody else is discharging the battery 100% every day, technically you would consider that both of those are cycling once a day, but one person is only using half their battery, which is going to make it last a lot longer. So what we look at is kind of the energy throughput. So the energy throughput is the area under the curve. That's what you're guaranteed out of the battery at the end of its warranty period. This is kind of analogous to like a car warranty where you're guaranteed 100,000 miles on your warranty. So we want to guarantee the kilowatt hours coming out of your battery, because at the end of the day, that's what really matters, right? That's what you are paying your utility company. That's what you're consuming during an outage. So our EverVolt standard, we guarantee a 30.2 megawatt hours, and EverVolt Plus 45.3 megawatt hours, 10 years with a minimum capacity retention of 60%. And we guarantee the energy throughput, or the years, whichever comes first. Again, people are going to use their battery differently, so some might be lasting longer than others, or setting different levels. One very important thing, always read the fine print, no matter what battery manufacturer you're using, including ours. Make sure you understand what you're selling the homeowner. There's a lot of fine print on conditions and things that have to be met throughout to satisfy the warranty. So now we'll jump into our brand new EverVolt energy storage system. So this is using our 18650 battery cell, which is inside of the battery pack. There's 351 of these cells in every battery pack that you see here. The basic design of the system, you'll see we have an inverter and a battery cabinet. As mentioned earlier, it's a very slim profile. The cabinet's 10 inches deep. It's roughly 66 inches tall, and then the two combined are about 46 inches wide. And you can place this inverter on the opposite side or lower, or various positions. You still have to stay within roughly 6 or 8 feet of the battery cabinet, but there is some flexibility there. And going on the simple philosophy, we didn't want to make it too complex for our distributors, for our installers, both on quoting homeowners and ordering SKUs and stocking SKUs. So we have two models, one AC coupled, one DC coupled, and then two models within those. So we have a standard and plus AC coupled and a standard and plus DC coupled. They're all the standard, whether you're doing AC or DC, is the same price, and same with the plus, whether you're doing AC or DC is same price. The main difference is you either get 4 battery packs or 6 battery packs, so 11.4 versus 17.1 usable kilowatt hours. And these are kind of the main components within those bundles. So when you go to order the system, you'll order that SKU, and these are the components that you get inside of it: the inverter, the battery enclosure, power hub controller, which is our micro computer, and then the battery packs. So this is just summarizing again, it's AC or DC, and then we have 5.5 kilowatts and 23 amps of continuous backup from a single system. That's an EverVolt Plus. Now, it is important to note that the actual grid feed-in is 5 kilowatts. So there are certain programs out there that you have to stay under the 10 kilowatt feed-in limit to the utility grid. So this does actually qualify that, even though to the backed up loads panel, we're actually providing 5.5 kilowatts of continuous. We do have great software, which we'll show you here shortly, and some of the unique things that we've mentioned: generator integration, the reliability with the batteries, and recyclability. So this is our AC coupled system, very kind of basic, where we have our inverter, you have the battery cabinet, and then you're going to have your essential loads panel, and then your PV array. In this particular case, we're showing AC modules tied into the essential loads panel, and then you have your grid connection from the inverter. So very basic, simple design. Again, frequency control. And with this, if you use Panasonic's AC modules, you do have truly a full Panasonic system going to the homeowner. Now we'll talk a little bit about DC coupled. So this is great for new systems, for existing PV systems with the inverter that might be on its last legs or out of warranty. And with DC coupled, we can have up to 6.5 kilowatts of PV DC into the inverter per inverter. So if you have a larger array than that, you can just add another inverter onto it. And then with DC coupled, we can actually stack systems now for increased backup power. So 2 EverVolts, we have 9 kilowatts or 46 amps. 3 EverVolts, we go up to 13 kilowatts or 69 amps. And for those that are doing the math, you're probably wondering, why is it 9 if you have 5.5 kilowatts of continuous backup? The reason being is because when you start to stack systems, you basically kind of lose the surge capability. And so we have a D rating and kind of safety factor built in. So, again, unless you're really doing a true plug load analysis, you're not going to be designing necessarily exactly for 9 kilowatts or whatnot. So these are, guidelines for system design. So these are the specs for the battery cabinets. Again, standard and plus. The main difference, you just have an empty shelf where 2 more battery packs go for the standard. 23 amps of continuous backup. And you will notice that with the standard, the backup power is a little bit less because we have 2 less battery packs. So we're at 4.4 continuous kilowatts of backup. Again, on the note of simplicity, we only have a few accessory SKUs here. So the system comes with our 200 amp CTs and meter kit. If you have a larger main service panel, that is an additional SKU and accessory. And then we also have a generator integration kit, which if you're going to be tying in the generator, like I mentioned earlier, and that's it. One important thing to note here, because I know some of you are experienced veterans of the energy storage space, this is a very similar battery pack into what we provide with the Generac system, but it's not the exact same. So please don't try and mix and match the 2 packs together because they are different. So what are the distributor benefits from this? Simple SKUs. Again, there's 4 basic SKUs with only 2 accessories. We will drop ship, so you don't have to even stock it in your particular location. Your customers, we can ship directly to them, whether it's East or West Coast. There's no minimum order quantity. You can actually have these battery packs stored for up to 1 year, and if you have to store them for longer, hopefully not. Hopefully they're moving really quickly, but for some odd case, if you have to, that shouldn't be an issue either. Just reach out to us and we can guide you on that. And you have the service and support from Panasonic. And from a distributor perspective, this really is the only solar and storage solution under one manufacturer that's out there on the market. From an installer benefit, it's very simple to design and install. It's compatible with all existing PV systems. I didn't really mention this earlier, but you can actually install more than 1 battery cabinet per inverter, so up to 34 kilowatt hours. And then something really important here, and this is kind of one of the main reasons why it's indoor rated, is that it's field serviceable. So 5 years down the line, 7 years down the line, 15 years down the line, if something happens to the inverter, if a battery pack fails or needs to be warrantied, you as an installer can simply do this out in the field. We don't have any special tools or any factory RMAs that we have to do for the entire systems. There's a user-friendly app, which we'll show you here in a second, and 10-year warranty protection. So this is the app. It's very simple. It probably looks familiar, similar to a lot of other apps that you've seen out there, but we want to just keep it with only the information that the homeowner installer needs. So you've got your basic energy flow, kind of your historical data, and then on the very last page, you have the settings that can be adjusted by the homeowner. So here's your battery reserve. And then you can change the modes between backup and self-supply or time of use. One of the installer benefits is we have a separate app that's just used during commissioning. So once you get your Panasonic account set up, during the installation, you'll be creating that homeowner account on your phone, and you'll be scanning the barcodes of the different components and setting up that system and registering it. So now we're going to change topics a little bit to change gears to some of the more concrete sales strategies. Hopefully you guys have a fairly good understanding of the capabilities and the power of the system that we're presenting here in particular. But a lot of installers we've seen, they get lost in the sale, right? So number one, set the expectation with the homeowner, right? There's a lot of really good marketing out there that for better or worse is telling a homeowner that you can back up an entire house, and there's a lot of fine print behind that. So set the expectation right. You don't want to go into a homeowner's residence and promise the whole home backup and set these unreal expectations to find that either their budget can't handle it or there's other reasons they cannot do it. So here's for the majority of the market right now in the residential space. The off-grid is generally not an option. That just comes down to simple budget, and then you want to get your incentives, right? So you don't want to give away free money. Whole home backup is generally not an option. Again, this is really down to the budget and buying a big enough system to really power a home. How big of a system can I afford? It's a great place to start. Hopefully you guys can start there with the homeowner, see what their budget really is, and then craft the right size energy storage system to that. So how do you size a system to handle the loads? If you know, if a homeowner says, well, I want 2 days of autonomy, or I want 3 hours of backup, how do you know what is actually capable with an EverVolt system? So there's a couple of different ways people are doing it. I guess this might go from beginner to advanced, I guess. So method one is you simply say you have one EverVolt standard system or one EverVolt Plus. You can choose 4 to 6 20 amp circuits from your main service panel to back up. So again, things we mentioned earlier, like the lighting, maybe television, garage door, internet, things like that. But you just limit them to the 20 amp circuits and call it a day, right? Method two, if they say, well, especially if it's a climate with very hot climates like desert areas and things like that, they have their AC needs. Really what you want to do is you want to get a clamp meter such as this shown here. You want to measure the current draw as that unit is starting up, because that inrush current is really going to be what makes or breaks whether you need 1 EverVolt, 2 EverVolts, 3 EverVolts to handle that system. Method three, very advanced and time consuming. For those that have done truly off-grid systems, this is the only way to do it in that case, where you have to go through, you actually list out all of your loads, you list out the specs of those loads, and you figure out, okay, how many hours are these appliances or devices going to run? And then at one particular time, how much current are they going to be drawing, right? This is definitely next level residential energy storage design. Method number four is, at the upfront cost, a little bit more expensive, but you can install a load control device, so something that will, such as smart circuit breakers or things like that, that can turn things on and off intelligently through an app or through automation. So now how do you size it for duration? So you can do some basic kitchen math. You can review the utility bill for daily kilowatt hours consumed. The average household in the US is 30 kilowatt hours per day. So you can take 1 EverVolt Plus, 17 kilowatt hours of usable energy, divide that by the 30, the average, or whatever the utility bill is for that customer, and then times 24 hours. So you get 14 hours of backup in that particular case. Now, you want to build a huge buffer into that because there's a lot of things to consider beyond that, right? Time of day the energy is consumed, the size of the PV array to recharge the batteries, the days of autonomy required. So, the safety factor that, we kind of just throw out there is 70%. So you take that 14 and that reduces down to 9 hours. Again, this is just like at the kitchen table, very quick and dirty math, but you wanna go as deep as you can for that customer to make sure that they're getting the system correctly designed for their expectations. So I guess we'll kind of wrap it up with, just keep it simple. That's going to be the best. There's a lot of confusion out there amongst homeowners, amongst installers, amongst just I think the industry in general on what, energy storage can do. Some are just keeping AC coupled and only doing AC coupled because they can literally do it as a simple price adder. You have your solar system that's priced separately, and then you have a checkbox that says, sure, 1 EverVolt Plus as a price adder to that system. It's always a great place to start with budget. How big of a system can I afford? The rule of thumb, buy as much battery as possible, because again, the homeowners are going into this usually thinking that they can back up everything, their electric vehicle, their AC units, the pool pumps, the jacuzzis, things like that. So, get as much battery as you can to give them the best experience. And again, simple design. You can choose to limit your circuits and selection. So I mentioned some of the load control before. So this is something that is hot off the press. We just announced it today, but we did partner with a company called Span. And what they do is they have a great product that does load control. It replaces the main service panel. So in this particular case, you do of course want to size the system, but you have a little bit more flexibility where you have up to 28 circuits that you can control via the app, and there's also built-in intelligence to automatically shed loads during a backup or during a blackout. And then also there's some additional benefits as well. So, you know, what does span eliminate? It eliminates a separate essential loads panel on the wall. So one less thing to put on the wall, one less thing to worry about. The labor associated with pulling circuits from a main service panel, you know, many times it's not that difficult, but I've definitely seen cases where it can be very difficult, and you're literally crawling through crevices to pull some of these loads from the main service panel over to a sub panel. The ability to install larger PV arrays. So with this, kind of the sizing limitations of the PV gets thrown away, because if you have separate circuits for PV for, you know, multiple PV inverters or microinverters, you can simply shed some of those during an outage. And then, you know, you're providing granular visibility into the home energy consumption and habits of that homeowner, which a lot of them really like. They want to see that. They want to know how they're using the energy, what's consuming the energy during that time. So we are doing a partnership with SPAN, with the installer gets a $500 rebate systems purchased through the end of the year. And the other big thing you're eliminating here as well is just having to have the homeowner choose which circuits to back up, right? Sometimes that can be a painful and not so fun discussion. So we do have an EverVolt certified installer training that is required to design, quote, and install systems. It's online on our website. The link is below. So you do have to complete this, and this will give you the warranty. This can, you know, obviously differentiate your business, being a Panasonic EverVolt certified installer. The requirements are pretty basic right now. We're just growing the program, so now's a great time to jump in there. You know, all you have to do is go through the training course, pass the quiz, and successfully complete one EverVolt installation. And similar to our HIT program, you know, this program will become full at some point, depending on the market. And so now's a great time to jump in there and try out a system. These are our representatives from Panasonic. So based on wherever you're located, and of course, you reach out to your local CED representative, and they can put you into contact with one of us. But we're more than happy to help you with EverVolt's system questions, design, or even, you know, obviously our solar side of things as well. And that's a wrap. So I know that was a lot of content. I think I hit my goal of 50 minutes. And again, if you missed anything, we will be sending this out afterwards, and we will be happy to address things now in the questions.
Hey, Dan, thank you very much for that great presentation. I really appreciate it. You should see some questions that a bunch of questions have come in. Do you you should see them on your screen.
I'm not seeing them here.
Here's a question for you. How does Panasonic intend to comply with the rapid shutdown requirements in the 2017-2020 NEC regulations?
Great question. And again, you know, a lot of these questions you can probably find in our training module, so I would encourage you to go through those. But to address this question is currently we don't provide a rapid shutdown device with our DC coupled system, but we are compatible with essentially any third-party rapid shutdown device. So the ones that we've specifically tested are with Tigo and with NEP. So both of those companies produce rapid shutdown devices that can be used with our system.
Thank you. A lot of questions are coming in. Here's one more question. So we probably have time for a couple more. How important is the choice of inverter as people are thinking about their system? And what should they be considering as they're looking at piecing together their total system?
Well, so obviously the inverter is a very important key component, and for those that have been in the industry for a long time, some are better than others. But I think what we try to do is really remove that decision from the process and again keep it simple. So if you're using our DC coupled system, then we're providing the inverter with whether you buy an EverVolt Standard or Plus. And then similar with the AC coupled, you can be using whatever PV inverter you want that's already either existing on the home or that maybe if you're using microinverters. And then with our AC coupled EverVolt, we are providing that inverter. And so we've matched the inverter size to the battery size in a kind of a holistic manner. So you don't have to really do the hard math of figuring, well, if this size inverter I'm installing here, how many battery packs should I install? You're either going to be doing an EverVolt Standard or EverVolt Plus, and that's all you really have to think about.
Excellent, thank you. There's a bunch of other questions. How can the battery be charged if the grid is down? That's an interesting question.
So it works basically the same concept in both AC and DC. So if the grid is down, you're going to have, hopefully you have solar. I guess you don't always have to have solar, but generally you're going to have solar that can recharge that battery when the grid is down. Or as mentioned, there are ways to integrate like an external gas generator that you can recharge the batteries. And hopefully if it's, the grid is down, it's only a few hours or so, and then when it comes back on, you can recharge them. But one thing to note on that is pay attention to the incentives, the ITC, the SGIP program. There are certain requirements for getting those incentives that a certain amount of energy comes from solar to charge those batteries.
Excellent, thank you. A couple other questions here is, what's the best way to estimate the battery degradation over time?
Yeah, so a really good question. And unfortunately, there's not just one general rule of thumb. So that's why, not only us, but really every residential battery or energy storage manufacturer out there is providing kind of a minimum capacity guarantee. So we know that, in the worst case, the way that the system is going to be used, like let's say you're discharging it fully every single day from 100% to 0%, it's installed in very hot climates, high humidity, all these various factors that can make a worst case situation. And then we determine that minimum 60% is where you'll be at. Now, as I mentioned, there's so much variability in all these different environmental factors that will, and the way that the battery is used, that the better you treat it, the less degradation you're going to get. Unfortunately, at this point in the energy storage residential space, you're probably just going to have to fall back on the minimum capacity guaranteed from that manufacturer, unless you want to kind of build in some of your own, buffer or warranty or reserves or whatnot as an installer that, with your experience, that you're going to be able to achieve 70% or 80%. And if anybody has any big applications, such as some more distributed resource type applications, feel free to send us those questions, or we'd be happy to maybe show you some of our battery degradation curves based on various environmental factors and use cases.
Excellent. There's a bunch of other questions. We probably won't have time to get through all of them. So the questions that we don't get through today, we'll email everyone back with answers. There is one here, a couple more questions. When installing a battery pack system, do building codes inspections require inspections from fire departments? Can you talk a little about fire departments and as it relates to batteries?
Yeah, so that's unfortunately not my particular area of expertise. I'm not sure if fire departments are required on every on the inspection itself. I don't believe so, but there are certainly fire codes that are unfortunately not standardized yet across the country, but implemented in various ways across. So I'd say the only helpful tidbit I can have on that is talk to your local AHJ, talk to your local CED rep. Maybe they can have some experience on the local level too, because there's really, as you guys know, in solar, kind of fragmented AHJ requirements across the country.
Excellent, thank you, Dan. Here's another question. Can you address the ability of the DC coupled system to reclaim clipped power when the DC to PV AC output of the output of the inverter? So how do you deal with clipped power from the PV system?
Yeah, so That's a great question. Actually, the first time I've gotten that. I believe the answer is that we don't recapture clip power, but we will send out, we'll follow up with the questions we don't answer and also with that one too, with the correct answer. So I will just verify that for sure.
Excellent. Last question is here, and also the span integration that you talked about and the promotion that you talked about is fabulous. Everyone's excited to take advantage of that. When will the span integration be made available in New England? So when is it available here? I'm in Boston. When is it available here?
I would say check with your local rep, but it should be available now. We just announced it today, so I think it's ready to go as far as I know. But definitely follow up with our local Panasonic rep and we can guide you.
Excellent. Thank you very much, Dan. So thank you everyone for the time today. During this quiet time, everyone's got a lot going on, and we really appreciate you taking your time out to sit with us and talk to us. We here at CED Greentech, we're very excited to work with you and help you on any of these products. As we were saying before, we have, as you might already know, we have 58 locations throughout the country. And if you reach out to us, we will start a conversation, especially about this fantastic offering from Panasonic. And we look forward to working with you. This, if you email us back at hello, if you jump to the next slide, Dan. If you email us back at hello@cedgreentech.com, we can send you all of your continued NABCET continuing education credits. So you just send an email to that address. We'll be able to email you back, once we process them, the actual certificates for your NABCET credits for this, this continuing education webinar. We want to thank you very much for your time today, both Dan, to you and to Panasonic, and to all of you being available to sit in with us and have this conversation. And we look forward to working with you in the future. Thank you very much.
Thank you very much, everybody.